Hi everyone. The purpose of this video is to show an example use case of the context reference store library against conventional agentic approaches you might be used to. Prior to starting this video, you should probably have knowledge in concept like caching policies, eviction policies, and a bit of compression. Most importantly, have knowledge in creating and running agentic applications. This is just to show the context for reference store usability. And to show that, I'm just going to be creating an example agent, which is going to be a political stock trading agent that actually gives you information about a certain politician recent activity in the stock market. I'm going to be using the Google's Agent Development Kit framework, which is pretty new. And the current farm I'm on is just a vanilla baseline version that demonstrates how much context data gets generated through multiple tool calls. And later we'll compare this against a version enhanced with the context reference store library to see the performance improvements. I'm not going to be writing the code for this part. If you want to see me writing code, it's probably going to be in the implementation of the context reference store itself. But for this, I'm just going to be doing a regular walkthrough, stating some of the tools that were used and why they were used, and running the application itself to just see what it does. Again, this is just a demo purpose application. It's not really enhanced to be fully capable of certain work type or workloads, but it's just to show the comparison between the base version and the context reference. Now I'm going to be starting with some of the imports. Um, I'm just going to be reading off this comprehensive documentation by Google's Agent Development Kit, and just walking through it. And if you probably notice, it's similar to my current file structure, except for the name of the agent, and that was intentional. According to what is said in the its method in its file, we should probably be having the uh, name of the agent being imported from the current directory. And in here, I'm not going to be showing you that, but I have my Google's Gemini API key and also a Perplexity API key. I'm going to be using Perplexity for like real-time searching of the web because the tool I just started using, and I'm trying to just add that to like for more web searching just to see its capabilities. I'm sure you can actually use some other tools. I know Gemini also has the feature of web search, but this is just my choice for now. So what I have here is basically a performance matrix. This is something I need to talk about more before we actually get into the tools. So I'm setting up the performance trace tracking. This is very crucial for our comparison. We need to measure exactly how much memory, time, and storage the vanilla version, which is this version, uses. We can actually show the dramatic improvement with context reference store. This part is for token consumption and memory usage tracking and serialization. For each contest, every single contest gets serialized and also deserialized, which also takes time and counts memory consumptions. I created a global performance tracker instance that will collect metrics throughout the agent execution. This is just for baseline measurements. And this function called track performance is going to be a decorator function that wraps each tool to track its performance. And every time a tool is called, we measure how long it takes, how much memory it uses, and how much data it generates, which was used somewhere here around the tools. We have to add my comment, just do tools. Going back, yep. Now I could just walk through it. This is just a start time I to actually start tracking doing that tool call itself. And this calls the actual tool. Some metrics are being calculated, and this tracks the memory if applicable. Also tracks the response time and the tool call count. We actually track the serialization size also. Remember I told you earlier we serialize and we deserialize context. This are also get used to get performance metrics like performance. We also have the print performance report just for me to see on the terminal for debugging purposes. And this function is used to actually generate a complete performance report that I'll use to actually compare against the context reference store version. Every metrics here should improve drastically with the library. We have the session metrics, token compressed consumption metrics, memory usage metrics, and some more. Each of them has like audio context itself, which is returning a dictionary. And we have this. The start memory tracking. We start memory tracking at the beginning of the session to capture the full memory footprint of the vanilla agent. And we also update the token metrics itself. This function actually updates our token counters. Tokens is basically tokens are our LLM measure input or output, and they directly impact API cost. Context reference store helps reduce token usage through intelligent caching. By reducing API usage, we're reducing cost. We can actually start memory tracking here, and this is the decorator being used for actually it. This is a tool to just get the current date using a datetime object. It returns a dictionary. I'm not gonna be going over the tools just to save time on this video, but like I said, it's kind of awesome you already know how to create an agent, including its tools. And I'm just gonna be pointing more on the search politician traits function. This is where the perplexity API is being used for actually searching real time, for searching real time data. This actually makes the search request using the Sonar Pro model, which is optimized for searching and provides grounded results with citations. Responses are extracted, and here's something important though. I need to ensure everything is JSON serializable. And perplexity might return complex objects. I convert citations into simple strings and return the search result as a clean serializable dictionary. If you notice how this tool generates the most context data, the content from perplexity can be hundreds of thousands of characters, plus also citations. This is perfect for demonstrating context reference store benefits because you can actually see it in a large data context. And if everything else goes wrong, we can actually cache and return through an exception. I'm generally using Gemini 2.0 Flash here, but you can actually use the Pro version. It doesn't matter. This is the description of the agent, according to what was stated in an example that was given here in the ADK documentation. This is the description of the agent, an instruction, and the tools list, which is similar to what we have here, but more enhanced. I'm just going to be running the agent. I'm using a virtual environment, Anaconda, and you can have to be in the root directory to run your agent. We're going to be in the root directory, which is stated here. And you can run your agent with several means. You can use the API in case you want to actually use it as a server, or in your terminal, or in the web version. Personally, I prefer using it in the web because of the UI is just much better. to run it, you can just run ADK web, and that should start a server for the web version, which is running on local host right now. And I'm just gonna navigate to the browser and go to local host. Yeah. I can actually try some quick prompt about like about stocks in relation with politicians. What is Nancy Pelosi's most recent stock rates? Let's take a few moments because it's gonna be taking calling some of the agents. And we have the information right now. So as of October 2025, uh they have not been disclosed yet, but these are the past ones she has been in. She has been invested in Google, Amazon, Nvidia, and Tempus AI. I don't know what that is, but this is basically what stock she's been invested in the past. As Nancy made any recent trades in Nvidia. I'm just using the ticker price for Nvidia. So this calls it to call validate um for validating ticker price, which is validate checks if the ticker price is correct ticker price. And it shows, yeah, yes, Nancy Pelosi has actually made significant trade involving Nvidia stocks in the early 2025. She used 500 call options, so 50,000 shares at a $12 strike price, and also sold 10,000 shares of Nvidia. We could also ask compare Nancy Nvidia stocks trades performance to the S&P 500 over the last 8 months. Like I said, this is just a sample. This could be scaled further, and the GitHub repository for this project is going to be in the description down below. And we have a response based on the results from Perplexity. So between February and October, which is today, she has mostly invested in stocks, NVIDIA. And with the comparison, we can actually see an increase of 40% in comparison to the S&P 500 performance, which is pretty impressive. And we can compare again Dan Crenshaw portfolio to Nancy Tech Holdings. This is just out of curiosity. There's not actually up-to-date disclosure of Dan Crenshaw portfolio holdings, but it's more on Nancy Pelosi's, and she's actually invested a lot in stocks. Palo Alto Networks, Alphabet, Amazon, and more. And you can see more like last question I'm gonna ask. What was Nancy return on our NVIDIA options from 2024? From 2024, is there doing some consideration and some calculation here? You have a return on investment of about 900%, which is pretty good. Interesting. Anyways, that's basically what the project is for. Now I'm actually going to be moving over to implementing the enhanced version, which is just context reference store, and showing you the capabilities of the context reference store and how it manages references, memory usage, token size, token consumption, and also API cost. Now I'm gonna head to actually add a test file, which actually tests the vanilla base version and just runs the agent on simulated stocks questions, and then returns some metrics. We can actually that's gonna be running. Gonna just stop this and try running the test. Yeah, this is showing some of the metrics. Like for example, you can see total context that was done for this test was 9, and each rate was 0, of course. Cache, because there's no cache in this is the base plain one without any added complexity or added optimization. Interestingly, we are using about 0.04 megabyte, and space saving percentage is 0, which is expected because there's actually no optimization done here. So let's just clear this. So I'm just gonna go ahead and start implementing the enhanced version, which actually uses the context reference store and other functionalities. Just gonna go ahead and create a new file and just call this political stock agents enhanced by move this into you. So I'm just gonna get started by importing a few libraries. So we need the date time for adding dates and times. So I'm just gonna import that date time. And we need JSON for data serialization and deserialization, and also API responses. We also need OS for operating system operations like file path, and we need system also for system specific parameters and standard error logging. And we need the time library. Just gonna import all three of them. Import OS, import sys, and import time. We need also access to trace malloc because it's gonna be used for tracking memory allocations in real time, which is a feature provided by the context reference store. Import trace malloc. And we also need access to functools for creating decorators and that tracks performance, and also temp file for creating temporary file in a cross-platform way. I'm going to actually tell you why we actually really need that. Import functools and import temp files. ADK uses functionality occurs in a single process, and context reference store uses context in a single process. And sometimes we might actually need to have like terminal user interface performance to actually show metrics and logs, which is a feature context reference store has. But since the ADK is run on a different process, you can access data from a different process. So we need a way to actually make the currently running process to save data, so a different process can actually access that data from a different file. I don't know if that explanation makes sense, but I'm gonna assume it does. So it's gonna be import. I'm gonna have to import threading for background tasks like memory allocation and memory retrieval. Import threading, and like I mentioned, we need to save path to files, so we can use the path library. But no, I'm just gonna be doing from instead. Import path. And we also need zones, like the time zones. Remember I mentioned like UTC, EST, and Pacific time. So from zone, because the Congress time is mostly in Eastern, so we also need Pacific time users to also access this information. So from zone, I think zone info, import zone info, and utility classes like from typing, import some data structures. So let's detect on my favorite, which is optionals. And we need a data class for creating data structures with minimal boilerplate. Data class, we need the field, and we need the collection module, and we just need a default data class from that. I think that's basically other helper libraries in it. And going into the crux, we can actually start importing our Google ADK agent class, the foundation of our agent. So from, I'm just gonna go over to this and just see where it was mentioned to import that. Yeah, so it's gonna be importing from here. Exactly. Importing our agents. And also because we need to access real-time web search capabilities, I'm using Perplexity here. I remember you can actually use just depend on Google specifically, but I'm just trying to get I just started using the Perplexity library and just try to use it for this. But you can use Google, it doesn't matter. But so Perplexity. And now we can call the reference source. So I'm gonna do context store import, and I'm going to be importing three things. I'm going to be importing context reference store itself, store, and I'm going to be importing cache policy. Like I mentioned earlier, we need knowledge of eviction policies and caching algorithms. Paul, let's see, sorry, it's wrong. Spelled it wrongly there. And so this caching policy involves like less recently used, less frequently used, time to leave, which is like an eviction policy. And we have the file and metrics adapter. This is what I explained earlier. Because of the single process ADK is run on, so key metrics being used, we need to save them to a file path, and then we can access them in a separate process, which is where we can start adding functionalities like adding a terminal user interface, which is a capability context reference store has. Make sure you can actually monitor your agent performance and see some of the metrics like memory usage, memory consumptions, your cache history, and your eviction policy, how well it's performing. Just gonna keep this like this. And also we need to import, since we want to use the terminal user interface dashboard, we can import it from context, see context store, the monitoring, and import traits, dashboard. Probably need a better name, a much cooler name for that, but that should suffice. Now we can create an instance of the class, which is let's just call it context store, and then initialize the class. So context reference store. Now with context reference store, we need to specify certain things. Bad. We need to specify certain things like we need the size of the cache, the amount of contents that need to be stored in the cache itself in memory. Can I set like a cache size of about, let me just put 2000. And also we set eviction policies. Eviction policy. So cache eviction policy that we can use allow you here. So least recently used. So make sure the least recently used item get evicted first. I cannot do compression because of the file size and tokens. We cannot compress context. Enable compression first. Should be true. And let's see compression algorithms. With compression, there's several algorithms you can use based on what you're trying to do. For lossless compression, I'm going to be using LZ4. Why I'm using that is because it provides a fast compression with good ratios. We can set the compression level to be 3. And I'm setting to 2 because it provides the right balance between speeds and compression ratios. And we need cache warming because that warms up the cache, warms up frequently used context in the cache. And we can set a memory threshold. to be 0.8. So this is like 80%. So memory threshold of 0.8 means that we use 80% of our available memory. I'm just gonna be duplicate most of those Pylance errors right now. Topic. Awesome. So we need a metric, but like I mentioned earlier, we need to actually make sure we can actually save data from a single process. And I'm just gonna make sure that it's global. ADK runs each request in a separate process. We need a file-based metric system, which means that a terminal user interface can access those data from that certain file specified, which, let's see, path. So we can set the path of the file to be using the temp file. You get temp directory of this and set it to be called, let's call it political doc. Enhanced matrix JSON because it's going to be a JSON file. And we can create a metrics adapter. So the reason for a metrics adapter is we need is because it's going to be an instance of the file metrics adapter class, which handles all complexity of like cross-process metrics, like cross-file metrics. And just like the fourth time I explained that is because you can reference files from a separate process effectively. Adapter because to file, let's call this, no, this subfile metric, exactly. And we can actually pass in the metric file path. Now we can actually create a background. We can actually create a function because we need a background thread to keep metrics fresh in the UI. In the UI, when I mean UI, I basically mean the TUI, which is the terminal user interface. I'm going to create a function that's going to be running continuously. We call it metrics time stamp reference. I'm just going to call it refresher. And it's going to be running continuously in the background so you can keep updating the UI itself. While true, I can just start the time. I created a, like an basically infinite loop that runs for the lifetime of the agent. And it sleeps for 2 seconds between updates. And call the matrix adapter again. But this time I update just the timestamp. And the adapter itself takes care of the rest. Like I said, the context reference store handles most of the heavy lifting. It's a setup part that makes it more a bit rigorous. Metrics adapter, the update. So it's update the timestamp. And that's it. Now we can already set a method that updates the TUI. Not really sure about the metrics of the TUI. Now we can actually create and start the background thread. And which is, let's create another called timestamp thread. Let's use the threading. The thread. Let's use target to be metrics refresher and the daemon to be true. The daemon being true means that it will actually exit when the main program exits. timestamp thread to store it. That we can start a thread, so it begins running in the background. And trying to see if I made a mistake, a logical mistake in the file, in the implementation. Yeah, I think we're good. We can use Python data class decorator for clean, efficient data structures. I can create a class called enhanced performance metrics. So it tracks the enhanced performance metrics with context reference store. And I could actually use the data class decorator, which becomes natively data structure. I'm gonna start tracking for token consumption tracking, which is similar to what we add in here. Which makes me, I think, I copy at least most of it. Yeah, a few of it. Can I track just track token consumption, such as, which is the same for this, and it's going to be used for comparison. I can also track my memory usage, and other thing I could track for is, again, I could track for the tool call times and the total response time, which is probably something I'm going to copy out. I think there's a difference here though. Since I'm using context reference story, I'm going to be calculating also context reference store specific metrics. I'm going to do in context storage, like the context storage times in milliseconds, which is gonna be a dictionary of string and floats using the feed. I'm gonna use the default default factory and set it to a list. And also I can store how long to store the context for, which is similar to this. Yeah, I'm kind of lazy. I don't want to keep typing. So context. So, but this time it's going to be context retrieval. Retrieval times milliseconds, but instead of a dictionary, I'm just going to keep it as a list. List of loads. And also how long to retrieve those contexts, which is that. And how long to store the object, the context, how long to retrieve the context. We can also have context IDs because for each context, there's an ID which is a reference to the context itself. So it doesn't, the context reference store doesn't actually store the object, it stores references. IDs, which is gonna be a list of string to field of default. But let me simply for factory. This stores the context IDs, which is it uses shorter 256 bits basically. And we also need cache statistics also. So we can actually look for the cache eats, which is going to be an integer based 0, and cache miss. This is 0. And cache it basically is the amount of number of times data was in a cache. And cache miss is the number of times we had to fetch from storage. And you can call track tool usage also. So tool call counts. These are metrics you need to account for if you want to see metrics on your TUI. It's not really necessary if you want to just don't want to see it working. But in the long run, I think it pays off because you can achieve some floors in your agent that way. So I'm gonna call the tool call, which actually just does, which is also a field itself, and same thing default factory. I'm gonna use the lambda under of default state here. So that integer, so it's gonna be a class of int. And I think that's it. But we can actually also mention, you know what, let's just keep track of the session also. So I'm going to keep track of the session start time. So basically keep track of session metadata. It's not necessary, but again, could help. So I'm just going to be doing default storage to be time dot time. And I'm going to be keeping track of the total number of query we count. And to be 0. So total number of query. Again, those two is actually not necessary, but you can keep it. So we can then instantiate the enhanced tracker. So I'm just going to call it enhanced tracker. Press enhanced. So now we have a single global tracker instance for the agent. And similar to this, where we add a decorator function, we could call the same thing, same decorator function. Now we can start tracking performance. This is the art of our performance tracking system. I'm just gonna be creating a decorator function similar to what we add here. Yeah, right here. But I'm just gonna copy in the same thing, almost similar, but now with this, I'm just gonna be calling this let me see, enhanced. Create what's this decorator class method wraps around every tool call similar to this decorator in the vanilla version. And similar to that, I also created the performance summary method. We just get a comprehensive performance also for comparison purposes. And returns a dictionary of several metrics is being collected. And what other is more advanced than the vanilla option because there are more data being collected, like context store matrices, like also caching and storage efficiency, cache size, memory usage. Moving further, I also get just to print in the terminal to make it more for debugging purposes. And moving on, we can actually get into the we can create an output function similar to initialize memory tracking. I'm just going to create the function called start against memory tracking. So it checks if trace malloc is already running, which is a function that was done here. and we already started thread. So it checks um if it's already, because if it is, then we don't have to start it anymore. But if it is not, then we could start it still. So trace malloc dot is tracing, and we can then, if it's not, then we could just start. You can just start tracking memory allocations, and of course start tracking memory allocations. So when this module gets loaded, you start tracking memory allocation. So now we can get to the part I'm kind of like TUI, the terminal based. I'm sorry, terminal user interface. This was like inspired by the Bloomberg terminal. So you can create like again a context reference store and do most of the heavy lifting. You just have to initialize some of its functions. So I'm just going to create a function called TUI and call it dashboard. And this is where we're going to be using this create dashboard functionality from the context reference store monitoring monitoring class, my bad. I'm going to try to let me just put an input first. It's going to be waiting for users. It's going to be waiting for user to press enter before starting. So please enter to start the dashboard. And then I'm going to create a file-based wrapper for the cross process metrics we were using before, like the matrix adapter that was used before. So it's going to be file store. So matrix adapter dot creates. So which is the file metrics adapter instance. Then we can call the create dashboard. Commits, and the create dashboard takes in the file store. I can still keep the metrics adapter. Yeah, we can just create a wrapper right here. Now we can initialize a dashboard, which calls the create dashboard mentioned and takes in the file store. It takes its so basically a file-based store wrapper. It takes its how many seconds it needs to be updated. So an update interval of let's see. I'm just gonna put 1 seconds. That's okay. And it's gonna be taking the path, which remember we had that earlier was just gonna cast it as a string and with a metrics file. Yeah. That should be good. Then we can then start this dashboard. That's it. You've already started the TUI dashboard. This starts the dashboard and everything. It shows the entire instructions on how to navigate through the dashboard. Just mark accept. So if this fails, maybe I use a keyboard interrupt. You can print. Let's see, what can I print? I can just do no line dashboard stopped. I use using, yeah, and also if there's like an except of one import error, you just do that as error. So I can just do print. Similarly, I can just so TUI dashboard requires additional Functional dependencies and error. Just print the error to make this an F string. And we can just do the file. So let's enter the last exception as E. And just print. I just call it a dashboard error. And, and finally, we can just print. She just prints a closing message. Let's see, just make it. And that by 80. I'm just gonna create 2 of those. And print TUI or dash word closed. The smiley face power. Now that should be fine. Now, this is where we start creating our agent. Typically, if you want to get started, you can just start creating your tools. Similar to what we add right here. But I don't want to repeat work I've already done. I'm going to be importing them. So from my directory, I'm going to be calling the and nope. That's going to call a circle import. So I'm going to be importing the get current date, get current time, calculate date range, validate ticker. And so the get current date, like you said, get current date, current time, get the date range. You validate tickers. So for example, you can actually validate Apple stock if the right ticker. If there's the right ticker for Apple is AAPL, I think you can check that. You can also search for politician trade. This is the most functionality where it searches for trades by politician. I think I explained it earlier. It uses Perplexity to search for real-time data, search politician trades. You can also calculate return, so you can provide a more accurate report. Like what's the return of a certain congressman trade from on maybe Apple stocks from 2024, and you can compare market. You can compare against other market. Like I think I showed an example with Nvidia stock and not supposedly investment in Nvidia stocks and the S&P 500. You can try it against the Nasdaq. You can also aggregate. This is just for statistical purposes. And you can also formulate search queries, so you can create more optimized query. Formulate search query, and finally we can format trade report. So it just gives a more detailed trade report. You can make it step forward. You can make it more advanced and make it downloadable. But I'm just gonna stick it where I have right now. Trade report, and now we call this function. Typically, I like putting this stuff at the top of my files, but I'm gonna leave it here for now. So now we can call the wrapper to which is this function we had here, and wrap it around every single method, which is again similar to what we did here. Now we can just do so get current date becomes wrapper of gets current date, and similar to then we pass me get current date. So you can be doing that for every so gets current time It's gonna be the same thing as trap. It's gonna be the same thing as the wrapper that gets time. So you're gonna be doing that for everything. Yes, I just figured the reading out. The wrapper class wraps the wrapper method wraps the entire method from this file, which are also the tools itself. We're basically done. We just need to instantiate the agents, which is this last part, and I could just copy the same thing, you know, and just, but this time around, I might just want to call it something different, like see what was the name I gave it here, and just use the same thing we had here. That should work for it, and awesome. Now I have everything with the instructions and the right tools. Remember, this is the wrapper. This is already wrapped from the previous tools in this file. Now, and now we have our agent. But one more thing, remember, this is going to be running the vanilla agent version. We want it to be running the enhanced one, so we update that. Now we have our agent ready to run. But first, because I want to run the TUI on a different dashboard, I can just create a shell script. It just runs the agent, which calls it basically calls this. Now I'm trying to see. It calls this TUI dashboard itself, but you know what? I'm just gonna cd into this directory and just create. Let's call it launch TUI sh and right. Now I have this. So I'm gonna create the right directory structure for that. So you can reference the root directory for the agent. So I'm going to put in one sign. And then name. Mm, 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 mm. That should be, yep. Should work directory name. So I'm just gonna be doing I see I'll try to say to agents the poly. Yeah, I think I'm really lazy, so I'm just gonna copy this. And it's the import. So I'm just gonna be, like I said, I'm gonna be calling this method here. So let me import on this. And now I can just call it launch. And that should work, I think. Let's see. Now we can try running, what should we try first? We can try running the TUI first. I'm kind of excited for that. Let's see what happens when I do that. Let me just create a new, because I told you, ADK runs in a single process. To create any other stuff, you have to create a different process for that. We can start let's just start a TUI on a different process. So let me see how that. So cd altitude, and now I can just start my shell script. You know what? TUI.sh. Oh, I see. I need to make it executable, so I'm gonna do chmx launch TUI.sh. Now that should work. I see where you're at. Wait, wait. Should work. And take a minute, yeah. Now we can just press enter. We're the dashboard. Just gonna move this mouse so you can see. Yeah. So we're in the dashboard and we can see some numbers here, but we can just hit X to reset the matrix and stats. Now this is running a different process, but they have same access to the same file. On this process, we can then run ADK. Again, you can use ADK terminal based, but I just prefer using the web. Again, better aesthetics. Now he's running on. You could just try getting local host. Trying to see where we can then choose our agent and try the bots then see velocity, most recent stock trades. Give them a moment. You can see that the context itself is stated to be 1. And we could start watching for other values very soon. It's searching for politician trades, and he has gotten it. Now we can have the context of 3. I'm just gonna ask them that question, like, has Nancy made any recent trade? Let me just try Apple. Now we can see we are getting more it's being compressed. The cache trade is 5%, space is being saved drastically. 3.33 times dynamically, and we have a space saved of about 1 kilobyte. We have a compression ratio of 1.2111, and also you can actually switch tabs. You get this, and you can get the memory usage here. It's a total context of 10 and it iterates. I'm using MacBook M1, so my memory is about 18 gigabyte. And like I mentioned, remember we had like an 80%. Let me see if I can find it. So we have 0.8 somewhere. But now it's trying to 0.8. So we had that set as a memory threshold. Now it's over in around 80%. I total memory used. And checking, I have a lot of stuff on my computer, so it's about 3.5 gigabyte worth of remaining storage space. You can see the alerts, which is just metrics and logs. Let's access something else. Let me ask for which stocks are mostly traded by politicians last month. So we have a low EAT rate. We have a low cash EAT rate because we haven't asked the same question twice yet. Compression of 22, which is pretty good. And an efficiency of 11 times. Nice. I know I mentioned on my when the readme is like 162. That was based on the test I ran then. But we have a space save of about 7 kilobyte. Again, this is more context. Think about it in a large point of view. With larger size and with more multimodal context like audio, video, and text, this is going to be much larger. And we have a compression ratio of about 1.3, 1.4-ish. So we have a 14.0% cache each rate. Yeah, so that's context reference store and some of the things you can actually do with it. And you can keep asking for more questions, or if you want, you can make it more multimodal. Um, so I'm just going to write another test similar to this, but this time I'm going to be testing it with the context reference store. And now we can actually compare both of them. So I'm going to be running the test. I created a new file for testing the advanced, which is similar to this, but instead this is calling actual the advanced, the enhanced version, which actually uses context reference store. I'm just gonna be stepping most this and just run it side by side. See, team split view. Nope, that wasn't it. You know what? Or I could get just test this. So I'm just gonna be running the test Python for this is the vanilla option, the regular one, without any added context reference store library. And we're getting this context size of 9 and this. And we can try the other one. So the enhanced version for simple tests, which is the same code as the vanilla, but we're getting the difference context size. Is gonna move in my cursor a bit up here. So let's make some comparison here. So we have it's like a total context of about 81. And we have like a total eats of 30. Uh, and we have um a total miss of 51, which is pretty okay. And the memory usage is about 20.2 megabyte. And the each rate is about 37%. And remember, this is just for a single like 3 or 4 prompts. The more prompts you give it, the better it becomes continuously. I think the one multiplier was actually eating about like 10x efficient, 11x efficiency in the TUI back then. The vanilla option is only just power on. There's no data persistent or like it doesn't remember stuff. For example, if I were to run the shell script again, cd um, and then just call TUI .sh. If I were to launch this shell script again, it actually remembers the last like it remembers the last total context itself. It remembers the each rate because it's stored in memory. It's stored in RAM. Uh, it remembers every step, but I can like make it forget the stuff. First, before doing that, we can keep going with the correction. There is an eviction itself and an eviction multiplier of 25x with a compression ratio of 2.3, about 2.3. And remember, the enhanced disk version compresses and reuses data. It reuses them until you actually clear the storage itself. And storage clearing is done if I actually hit the reset matrix, which is the X. I'm not going to do that right now. I'm just going to compare. And the enhanced you might be thinking is larger. The enhanced is actually saving more because the total memory about like memory is about 0.1 megabyte. And context reference store is actually using 0.27 megabyte. That might seem like probably like almost doubled what it was supposed to use, but that was just for a single one. But with context reference store, if you're to run it again, it wouldn't increase anymore. It wouldn't increase as much as this because that is referencing stored data. And so basically in terms of like RAM access time, technically it's supposed to be using about 120 nanoseconds because it's a RAM. And I couldn't actually store it in L1 or L2 or L3 cache because the context size is much larger than those ones, so I can't actually use those. I actually use the RAM to store data on. And because of the added overhead of several Python computation, it escalated to about like zero point 0.1 seconds in terms of retrieval time. And which is basically with the concurrent load and 20 threads. I think that's it on context reference store. I hope this video was informative.